Welcome to this video on grid management and large-scale batteries. On this channel, Synergy Files, we aim to inspire budding engineers and technicians for a better, more sustainable world. So please do subscribe to our channel and stay updated. The electric grid system brings power to our houses, schools, institutions, and our industry. The energy in the grid is constantly monitored and managed. We can appreciate that when we switch on a light or turn a heater on or turn any machine on for that matter, the grid provides power in real time. But where does that power come from? Is there additional energy in the grid? What if we simultaneously turn on a lot of machines? How would the grid fare with that? We will endeavor to answer all these questions in this video, so please do watch it till the end. The electric grid is interestingly influenced by every device that is turned on or off. But as the scale of power in the grid at any given time is very high, the effect of each individual electrical device is minuscule. The effect on the grid is the change of frequency of power, and to a certain extent it has effect on the voltage too. Remember, we get our power at a certain frequency that could be 50 Hz or 60 Hz depending upon what the standard and utility infrastructure is in your country. When there is demand and appliances are being switched on, the grid frequency drops. On the other hand, when there is more power in the grid being pushed into it by the generation side and there is less energy being consumed by the end users, for example in the night when a lot of lights are being turned off, let's say, then the grid frequency goes up. Grid management companies are responsible for keeping the grid frequency within a certain range, because if the frequency of power one receives is very high or very low compared to rated power, then it can damage electrical or electronic devices. For instance, in the UK, a company called National Grid is responsible for managing the grid frequency. The range it tries to limit the frequency to is 49.5 Hz to 50.5 Hz. Maintaining grid frequency in this range is not an easy task. Both the demand and supply are constantly changing. Sometimes the grid management companies ask the energy generators to ramp up the energy production. Sometimes they may ask the energy producer to reduce the energy generation or even shut down the power plants. It is a complex system that is constantly monitored. Fortunately, because of certain patterns of social behavior and data availability on the patterns of seasonal, daily and hourly energy usage available to the grid management companies, the task is made slightly easy. There is a link in the description section that will take you to a website where you can look in real time the frequency of grid in the UK and the generation of energy from various power plants, from renewable to nuclear power plants. It is a very interesting web page with loads of data, and I would urge you to spend some time on this after the video. We are now living in an age where energy generation from renewable sources is becoming extremely important, particularly in light of climate change. One of the problems with renewables is intermittency. Wind can suddenly drop, and likewise cloud cover can severely disrupt the output from a solar farm. It was because of intermittency and the complexity of grid management, renewable resources were not looked at favorably by utility companies. And it is understandable that there is some degree of control and consistency in the output of a coal power plant, a nuclear power plant, and even power from a gas turbine. Therefore, whenever power purchase agreements were drawn, renewable power plants did not get the best rates compared to conventional sources. However, the tables have now turned with the arrival of grid-level power storage. Large batteries that have the capacity of hundreds of megawatts are slowly cropping up on the power landscape. And recently, Tesla made headlines by delivering one of the biggest battery to Australia in record time. The arrival of large-scale battery has been a breath of fresh air not only for renewable energy generators but also for grid management companies. The energy buffer that the battery provides takes out the intermittency problem out of the equation and also removes the frequency variation in the grid. Tesla's battery in Australia is rated at 100 megawatts of power and has a capacity of 129 megawatt hours. It has been reported to have saved 1 million Australian dollars or about 800,000 US dollars just in a few days after its installation. This mega saving was done by the battery just by storing extra energy when it was not needed and delivering it during peak times. Many experts have long suggested that large-scale energy storage solution is the holy grail for the advancement of renewable energy. Grid-level batteries are here, and with them, the cheapest and the cleanest of the energy sources, that is renewables, have also become reliable. And with this, the video is concluded. We will bring you more videos on large-scale batteries and changing grid systems, so make sure you subscribe to our channel. If you learned from the video, you know the drill, please hit the like button. Thank you for your attention.